Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. Now in these live sessions we have been discussing about the mole concept, and now I welcome you all to the session 3 of this discussion. In today's class we are going to throw some light on the concept of average atomic mass. On the concept of average atomic mass. Well, this average is quite similar to the average which you know in mathematics, and I will make it much more simpler for you to understand this. So now let's get started. Now I've taken the example of chlorine. Why so? Well, try and remember from the table of atomic masses that I have told you. Do you remember what was the atomic mass of chlorine written there? Well, chlorine's atomic mass was written around 35.5 grams per mole. Now think about it. What is atomic mass? It is actually number of protons plus number of neutrons, right? It's just that. So tell me one thing, can we have half proton or half neutron? No, right? No matter, it is 2 plus 2, it will come out to be 4, it is 5 plus 5 or 5 plus 6 for that matter comes out to be 11. It will be always a whole number, right? So how did we get this 0.5? Well, answer to that question lies in this session and in this concept of average atomic mass. Right. Now let us move further and understand this concept. Right. Now suppose I have a huge sample of chlorine gas. Suppose this is a sample of Cl2 gas, Cl, right? Sample of Cl. Now from this huge sample of Cl, I take a small amount sample separately, and in this sample, you know, if you analyze this sample, you will find that this sample contains two types of chlorine atoms. One is chlorine 35 and the other will be chlorine 37. 35 and 37, all of you know is what? It is the mass. Now, let us pause for a little bit and let me revise it for you. What are these chlorine 35 and 37? These are nothing but isotopes. Right? These are nothing but isotopes. Now let me revise your isotope knowledge also. See, isotopes are nothing but what? These are atoms with same number of protons but different number of neutrons, right? And since the number of protons and neutrons, number of protons are same and number of neutrons are different, and because the mass number is number of protons plus number of neutrons, this mass number comes out to be different, as is in the case of Cl35 and Cl37, correct? So these two are isotopes. So in a sample of Cl which we have taken from the air, you will have around 75% chlorine 35 and 25% chlorine 37, right? Now what do I mean by average atomic mass and how do we find it for chlorine? Now we have to finally arrive at this value. Let us see, do we arrive at this value or we do not? So now on this journey of calculating average atomic mass, let us recollect what we already know. We know that moles is equals to what? mass of the substance divided by molar mass. Correct? And if I take molar mass here and moles here, molar mass will be equals to mass of the substance divided by moles, right? Now simply transform this equation into an equation of average molar mass. If you see here carefully, we have M average. This is nothing but average molar mass, and this is on the numerator we have mass of the mixture divided by total moles of the mixture, because now we do not have a single substance, we have two. We have Cl35 and Cl37, so it is a mixture. So most total mass of the mixture divided by total moles of the mixture gives us what? It gives us the average molar mass. And this 35.5 is nothing but what? This is your average mass, right? Another formula here, average mass is W total divided by N total, right? So keep this formula in mind as we move forward. Right. Now, after understanding this formula of calculating average mass, let us understand what is mass percentage or mole percentage for a mixture. Because if you see, I have written here percentages, right? This is percentage abundance. Okay, percentage abundance, or I will say this is mass percentage. Right. Now from this mass percentage, how to go to that story is way ahead. So now isotopes basically differ in their masses, right? So suppose I have a mixture of isotopes, isotope A and isotope B. In this mixture, mass of isotope A is WA and mass of isotope B is WB. Similarly, moles of isotope A is Na and of B is NB. So simply average molar mass will be what? It will be weight of A divided by weight of A plus weight of B multiplied by 100, right? That will be your average molar mass. Well, I think there is an error here. Don't do like this. So we are discussing about mass percentage, right? This expression should be for mass percentage. So mass percentage is mass of A divided by mass of A plus mass of B multiplied by 100. This is your mass percentage of A, right? Similarly, if I want to write mass percentage of B, that will be mass of B divided by mass of A plus mass of B multiplied by 100, right? That is how you calculate mass percentages, right? The given mass by total mass by 100. In the same way, we calculate our percentages in examinations. The given marks that you get divided by the maximum marks that you have multiplied by 100. So this is your mass percentage. So remember, we have given moles also. So we can also calculate what? We can also calculate moles percentage in the similar way. Moles of A divided by, this is what? N total moles multiplied by 100, and moles of B is NB divided by Na plus Nb. And similarly, you have also learned about mole fraction. This is your mole fraction. So this part is nothing but mole fraction. So these are some of the ways in which you can talk about the amount of a particular component of a mixture, right? Now after knowing this, let us address the elephant in the room. What we were actually doing? We were actually calculating your what? Average mass, right? So suppose I have an element Z which has this as your molar mass, average molar mass. Now this Z has two isotopes, Z1 and Z2, with molar masses M1 and M2. Now percentage abundances of both of them are A% and B%, right? Now do you remember the average molar mass formula which we had derived? It was what? It was weight, total weight divided by total moles, right? That it was. Now how will you calculate the total weight? How will you calculate? We know that moles is mass upon molar mass, right? So moles multiplied by molar mass gives you the mass, right? So simply multiply this, right, percentage, whatever percentage you have got, multiplied with the molar mass A plus M2B, right? You will get the total mass and then simply divided by total number of moles. So N total will be A plus B. And the formula for your M average will be M1A plus M2B by A plus B, right? This is your formula, always remember this, and this is the formula that will help you in solving questions. Now this can be your mole percentage or it can also be your mass percentage, does not matter, all of it works. Remember here I am substituting the percentage values, right? Right. So let us move on to the case of chlorine. What do we do here? Chlorine, I told you, has two isotopes, these, right? So now let us take this formula and calculate the average mass of chlorine. So the percentage is 75. So 35 into 75 plus 37 into 25 divided by 75 plus 25, right? By 100. Now if you calculate this, all of you will be astonished that this comes out to be exactly around 35.5 grams per mole. Yes. Yes. The chlorine's mass or molar mass that we have written in that table is not the actual mass. It is actually the average mass that we have written. And it is this average mass that henceforth after this you will use in all your calculations regarding chlorine, right? So this brings me to an important conclusion. What is that important conclusion? That is, if the atomic mass of an element is fractional, fractional means if it is in a decimal, right? If you are getting a decimal, then it may exist as a mixture of isotopes, right? So if you have atomic mass as fractional or decimal, it indicates that that atomic mass which is written is nothing but a average atomic mass, and that element exists in nature as a mixture of isotopes, right? Now let us solve this numerical. Answers I have already written here, but still let us solve it. Now what does this numerical say? It says that boron exists in nature in the form of B10 and B11. Its atomic mass of boron is, atomic mass of boron is 10.8 AMU, then the mole percentages of B10 and B11 in the mixture will be. So we have to tell this mole percentage, right? Pause this video for a little bit. Try and do this yourself before I finally tell you the answer. Right. Okay, have you tried it? I hope you have. So let's get started. So we have boron here, right? Boron has two isotopes, boron 10 and you have boron 11, right? Now suppose the mole percent of boron 10 is X percent. If the mole percentage of boron 10 is X percent, then if this is total 100 moles, suppose, then the mole percentage of this will be 100 minus X. Correct? Now the things are much simpler. Gaseous mixture is our next topic. Right. So where we can use this formula, please tell me that. Well, we can use this formula if we have a homogeneous mixture of gases or alloys. Homogeneous, you know, right? Same everywhere, right? Homogeneous is your same everywhere. Like we have in this atmosphere, oxygen, nitrogen, hydrogen all mixed together. Same way, if I have a homogeneous mixture of gases and I need to find average molar mass of this mixture, then I can again use this same formula, which is total weight of those gases divided by total number of moles. So again the same analysis, right? If you have this one, right, two gases, right, suppose this is gas 1 plus gas 2 mixture, molar mass of gas 1 is M1, gas 2 is M2, moles of gas 1 is N1, moles of gas 2 is N2, mass will be molar mass multiplied by moles. So this gives you the total mass divided by total moles, gives you the average of gases mixtures mass. So this is the formula that you have to keep in mind in order to move forward with these questions. So moving forward, let us have a look at this question. Carefully read this question, I am giving you time. Calculate the molar composition of a gaseous mixture containing NO and NO2, whose average molar mass is 38. Pause this video for a little bit and try and solve this question before I solve it for you. Right? Done and dusted. So let me solve it for you. Now we have a mixture of, so this is your mixture. Right? This is your mixture where you have NO plus NO2. Right? Let me just reduce the length of this. Right. So now let us first calculate the molar mass of NO and the molar mass of NO2. That is really essential for you to do, right? So nitrogen's mass is around 14, right? Oxygen is around 16. Similarly, nitrogen is around 14. Now you have two oxygens. So twice of 16 becomes 32. If you add this up, how much will you get? Everyone? You'll get around 30. This one if you add, you'll get around 46. Right? 46. So So these are your M1s and M2s. Now what else can we do here? Molar masses are done. Molar composition, nothing. We know this formula, right? This formula we already know. M average is equals to mass of 1 into A. A means, let it be N1 for more clarity. Mass of N1 plus mass of 2, mass of N2 divided by N1 plus N2. And we need to find the value of N1 plus N2. See, this average mass is already given to you as 38, right? It is given as 38, so substitute here as 38. The first mass is around 30, right? Now here, see, if you do it like this, if you write it like N1 plus 46 N2, you're going to be at a dead end. Why you're going to be at a dead end? Because N1 and N2 you do not know. You need to know one of them in order to solve this equation. So we are going to change our approach just a little bit. How we are going to do that? Simply, instead of working in terms of moles, we will work in terms of mole percentages. I think when you talk about composition, they are asking about mole percentages. See, remember this molar composition, they are talking about mole percentage, right? Because moles we cannot calculate from here. So the molar masses are done. I am going to clear this out, right? Right. So you have a mixture and the average which you have calculated or got is equals to the actual average. Then remember that in this case, in this particular case, what will happen? In this particular case, both of them will be present in 50% plus 50% mixture. Right. Right. So this is what we have learned from this question. Now moving forward. So next question is, calculate the average molar mass of a mixture of gases containing O3 and O2 in 2:1 mass ratio. Try and attempt this question yourself, right, by pausing this video for a little bit while, and then I'll be here to give you a detailed solution. Right. Now let's get started to solving this question. At the very first go, calculate the molar mass of O3, 3 into what? One oxygen is 16. (48 grams per mole). Right, molar masses are done. Now this ratio is what? This is a mass ratio. What does that mean? So 2:1 is the mass ratio of O3 to O2, right? Mass of O3 to mass of O2. Correct? O3 and O2 in 2:1 mass ratio. Right. Now to calculate average mass, we have learned about many formulas, right? We have learned about almost two formulas. One is in mole percentage and one is in the form of moles, right? We have not learned any formula in the form of mass, right? So quite naturally we have to convert this mass to moles in order to apply that formula. So now let's get to it. Divide here on top by the molar mass of O3 and divide bottom by the molar mass of O2. Let's do that now. So 2 by 48 divided by 1 by 32. Now here also if you divide the mass of this by molar mass of O3 divided by mass of O2 divided by molar mass of O2, what you are bound to get? You are bound to get what? You are bound to get moles of O3 by moles of O1, ratio of their moles. O2. So now let us get that ratio. So you have 2 by 48. The other one becomes reciprocal as it goes up. 32. So we get a ratio of 4:3, right? This is the ratio that we are getting, right? Now let me clear this up and write down what we have actually got. Note this down and let us move forward. So we have got a ratio of 4:3. So NO3 4:3. Now we can simply use the formula, right, which tells us that M average is equals to right. Substituting these things in the formula, right. What was the mass of O3? Molar mass was of O3 was, let me just get it, yeah, 48 multiplied by 4 plus 3 multiplied by 32 divided by 4 plus 3, which is around 7. If you solve this completely, you are bound to get the answer as 288 divided by 7. Right? That will be your final answer. And that is how you solve such questions. Now after these numericals, let us move on to another concept which is often used in finding the molar or molecular masses, and that concept is of vapor density. Vapor density. So what is vapor density? Simply, it is the density of any gas divided by density of H2, right? Now, normally this density of gas and density of H2 is not given to you in question, right? So this is not given to you in question. We have to simplify this formula further. For simplifying that, let me tell you an equation, right? See, for an ideal gas, we have an equation. You'll get to know about what is ideal gas, what is not ideal gas in your upcoming chapters. But for now, let us only consider that we have an ideal gas. The equation goes like this. We have PV equals to nRT, where P is what? P is the pressure of gas, obviously ideal gas, and then N, volume, V is volume of gas, N, number of moles of gas, and R is your gas constant, and finally we have T, which is your temperature, right, which is temperature. Now this is an equation followed by all ideal gases. So all ideal gases follow this equation. Now from this equation, we have to derive an equation for what? An equation for density of gas, this part. How we will do that? First note this down and let me get you through that derivation as well. Right. So we know PV equals to nRT for now for every ideal gas. And what is N? N, I have told you, is the number of moles, and we know that number of moles is what? Given mass upon molar mass, R into T. Now tell me, what is density? Well, any normal density, if I talk about, density of anything is mass by volume, right? It is mass by volume. So if I take this molar mass this side, this volume below this, you will get VRT. What is this? W is the weight or mass divided by volume. This is nothing but, I can say it is density. Dm equals to dRT. You can remember this equation by a mnemonic which I say sometimes. I have seen it many places. It is, mnemonic is, yes, I don't want to read it, dirty Pm. Means dRT equals to Pm. So from this equation, derive an expression for density. So I can say that Pm by RT will be your density of any gas. Right? Right. So substitute all that here. Density of gas is P of gas by RT divided by P of H2 by RT. Remember, vapor density's definition tells us that it is the density of a substance with respect to density of H2 at the same temperature and pressure. And I told you, when I talk about with respect to, I simply mean division by that particular thing. So equals to dirty Pm d R T, right? From this we can calculate the molar mass of gas mixture. Density is 3.2 grams liter inverse. See, I did not tell you R is 0.0821 atmospheres liters Kelvin inverse, right? When you have pressure in atmospheres. So substituting that here, right? Multi density R and finally temperature also. Pressure is 2.463 atm. Right. If you multiply these terms, you will get around 24.63, right? You will get around 24.63. It will come out to be 8.21. Okay, right. If you further solve this, you will get a value of density. Now let us see what value do we get. Let me just check this calculation as well. If you multiply 100, it comes out to be 8.21, 3136, 24, 24.63, right, I am correct. Right. So now if I try and cancel this out, just remove the decimals here. This will be 10 raised to power minus 2, this will be 10 raised to power minus 3, and these will get cancelled out, right? So you have 3.2 multiplied by 10, or I should say you have the value of 32 grams per, right? So with this we have calculated the molar mass of the gas mixture. Now once we have the molar mass of the gas mixture, now life is easy from now on. How is it easy? You have to use the same concepts which I have taught you earlier, repeat them again and again to get the final answer. Now earlier, instead of this density, molar mass was given to you directly. Now you have calculated that molar mass and we are going to use that molar mass further to find the molar composition, right? So let me just clear this, right? So the molar mass that we have got is around right. Now by x, 100 minus x, right? We can do this easily. Multiply the percentages with molar mass of nitrogen, which comes out to be 14 into 2 plus 3 divided by 100. Solve this equation out, you will get the values as 80 and 20 percentages. So this is how you apply the concept of vapor density. So this was the last concept for today's class, right? What I want all of you to do is, finally, if you are liking these sessions, if you are understanding each and everything that is being taught here, then the next natural step should be to scan this QR code and learn more about our courses and join us on this journey.
राइट सर।
कितना टाइम हुआ?